Imagine robots and prosthetics that don't just move, but feel. Professor Ravinder Dahiya and his team at Northeastern are pioneering printed electronics to create lifelike electronic skin. From restoring touch for amputees to enabling safer human-robot interaction, his research is shaping a future where machines and humans connect more naturally than ever before.
I'm Ravinder Dahiya, professor in EC department. I joined university about 2 years ago, and my research team focuses on electronic skin for robotics. And to this end, we develop our own technologies, which involves printed electronics. Well, when we look at electronic skin, think about grasping a cup of tea. You feel the temperature, and that itself makes a lot of difference to how you can taste the drink, the tea, for example. And now think about a scenario where amputees have lost their limbs, and with that they lose the sense of touch. Now, that makes a lot of difference when it comes to daily life and appreciating or perceiving the world. And now if you extend that thing to robotics, you can now imagine robots without sense of touch, how safe they can be when you interact as two humans would do. So you have to have electronic skin all over the body. Then we are looking at a scenario where sensors and electronic components, they will be placed on or integrated on flexible surfaces or substrates. What is available today are electronic chips which are rigid. They don't bend, and if you try to bend, they are made up of brittle materials. So when you try to bend, they will essentially crack. So there is a fundamental mismatch between what is available today and what is needed for many of today's applications as well as futuristic applications. We have adopted the new approach, which is essentially printing of electronics. We get the electronic structures on the flexible substrate. We take it to our printers there. So these are high resolution printers that we have in lab. So we can print nanoscale lines to about 10 micrometer lines. So this is already state of the art when you look at printed electronics. These are kind of nanowires printed on this substrate. So it's very difficult to see with bare eyes, but these are the kind of nanoscale electronic layer which are then processed. For example, printing metal on top of this. In past, we used to deposit metal in clean room, but now we have this capability to print directly on these structures. So printing has a lot of advantage. In a sense, you are printing as much material as you need. The traditional practice is that you deposit metal everywhere and you etch from the locations where you don't need it. Yeah, so it's complete, right? Yeah. And now it's going back. Right. So once you get nanowires transferred onto the flexible substrates, next step is to deposit the metal lines or the print metal lines, and that's where we have, as I mentioned earlier, we have in the lab state-of-the-art printers.
Yes, so we have in our lab 3 state-of-the-art high-resolution printer. One of this is humming. So here you can see the printer in action. So one of the advantage of this printer that we can print ideally on any substrate. That would be papers, plastics, or any other stuff. So coming to the printer side, so here we have a very fine nozzle, diameter of around 5 micron. This is filled with the silver ink. There is a substrate polyimide which we are currently printing. This is the camera which we are using to focus and to align our substrate where we have to print.
We believe that printed electronics can disrupt the current micro-nanofabrication approach, can open new direction for the semiconductor industry while helping advancing areas such as robotics and wearable systems. So I'm seeking collaboration with colleagues who are working in these areas so that we can come together, make 1 + 1 11, and quickly provide some solutions to the society. That's one aspect. And then second, of course, any such research, complex research, requires considerable amount of funding. We are trying our best to get the funding from external resources, and university also has provided us some funding. So that's a continuous process from the wider community, from both industry as well as academia. We are happy. We would welcome any collaboration that also leads to funding to support our research. And we have also developed our own printers, and that's where we are also getting actively support from Center for Research Innovation at Northeastern University. So we have filed a couple of patents already, and more are in the pipeline. And we are also aiming to develop initiate a startup in this field with various variants of printers that we have developed in-house, and that we believe that everybody should be benefited from our research. So we are open to sharing that expertise and those resources with universities, with the industry, and hopefully this will benefit the larger society as well.